Physicists, today we are going to be talking about the core practical that you need to know, or one of the core practicals that you need to know for electricity, which is about resistance and length, okay? So listen up, I'm going to tell you everything you need to know to get 6 marks on this question if it comes up as your 6 marker. So let's start by thinking about the relationship between resistance and length. So as resistance increases, the length of the wire is increasing, okay? So as we increase the length of our wire, the resistance is also going to increase. Now, this is because we've got in our metals, like in our wire, we're always going to be using a metal, right? One of the main reasons we use metals as our wires is because they're really good conductors of electricity. They're really good conductors of electricity because they've got delocalized electrons, which I'm sure you remember from chemistry. But if you just need a quick refresher, they are the electrons that float around. They're not attached to a particular atom, but they can float around like in and out of all the ions, okay? And this is what makes metals such good conductors of electricity. So as the wire gets longer, we've got more metal ions. So as the electrons are floating around, they've got more chance of hitting a metal ion, and that's what causes resistance. So as the length of my wire gets longer, my resistance increases and increases and increases and increases, okay? So what I need to do with this experiment is I need to start with some sort of power source, okay? I'm going to use a cell. Then I need to measure resistance. Now, there's no such thing as like a resistometer. We can't directly measure resistance. We have to measure the potential difference using a voltmeter and the current using an ammeter, okay? Now, remember, we set an ammeter up in series with the component we're interested in measuring. So we set it up next to it, okay? So down here, I've got my length of wire. It's attached with crocodile clips. So these will be my crocodile clips. Crocodile, there we go. Clips. Here is my length of wire, and my ammeter is next to it because that's the bit I'm interested in measuring, okay? Now, I need to measure the potential difference as well, okay? So I need to measure that potential difference over the component I'm interested in measuring. So I'm going to put my voltmeter here. It's going to go over that length of wire. Then, what I need to be able to do is I need to vary the length of this wire. So what we normally do is we grab a meter stick, we clamp the wire to the meter stick, and we just move the crocodile clips up. Every time you move the crocodile clip, you're going to want to make sure you go up in like an even step. So I go up in 5 centimetres or 10 centimetres. You're going to measure the potential difference and the current in the circuit. A top tip to make this experiment more accurate is to make sure that you turn your circuit on and off in between every reading, because what you don't want your wire to do is to heat up. If you leave the wire on, it's going to heat up. So to make this experiment more accurate, I want you to make sure that you turn your circuit off in between every reading. So let's think about our variables then. What am I changing? So the independent variable is going to be the length of the wire. The dependent variable, so what changes, is going to be the resistance of the circuit, and my control variable is going to be the potential difference of the supply. Like, I'm not going to suddenly start halfway through the experiment using like 2 cells or 4 cells or like change what I'm using as my power supply. I want to make sure that that stays the same all the way through, because what I'm going to change the length and see how that changes the resistance. I don't want anything else to change. So then I'm going to calculate my resistance from the potential difference and the current using this equation here. And then I'm going to draw a graph of resistance versus length. And you should find that it's a nice straight line that goes through the origin, okay? And that shows that the resistance and the length are directly proportional to one another. Thank you so much for watching. I hope this video is going to help you absolutely ace your next 6 marker on this core practical. Don't forget to subscribe to my channel if you want more content just like this.